Lab 5 today. So the purpose of this lab, for the introduction, the purpose of this lab is for the students to observe a projectile motion of an object and with the tracker analyze the x-axis distance traveled in regard to time to plot the actual time and using glow script to plot the predicted graph. In addition, the student will determine if the object will safely hit the ground or would have hit an invisible wall if there was a wall at 0.5 meters distance from the initial position. And just for like a preview of the results of the lab, then it does hit the wall if there was a 0.5 meters because the ball traveled 0.91 meters, so it would have safely hit the wall. And the main principles used were Newton's second law, which says net force is equal to mass times accelerations, and the equations used were the net force, which is in the y direction, the mass times gravity, and the velocity update formula and the position update formula, which we will discuss further in the coding section. And for the experiment, the observed position is that the initial condition of the tennis ball is 0.058 kilograms. Initial velocity of x is 2.2754. Initial velocity of y is 0 and height is 0.762 meters, and the system is tennis ball and the surrounding is gravity, and this is how it's shown as it is graphed. And the predicted position, I had the initial ball position is 0.762 because that was the height I threw the ball from, and the initial velocity it is 2.2754, and then there in the while loop it goes around, and in the net force is there's a negative y net force, which is the mass times gravity, and the velocity update formula, which updates the velocity, this updates the position, and then I made sure that it prints the x instead of the y positions, and from there I will take the numbers that are printed here and plot it into the Excel graph which we will see in the next slide, and we check to see if the ball position was greater than 0.5 meters. It would say it hit the wall, and it would say if it didn't, if it was lower than that, it would say it did not hit the wall, and as it shows, the ball did hit the wall because it traveled 0.91 distance. And so this is the comparison, and this is the comparison. And this shows the observed model, which is from the tracker, and this is the computational model. And this just shows that there is some discrepancy, and some possible errors for this project is that one, I'm not a machine, so I couldn't have perfectly thrown it in only in the initial x velocity direction. I threw it probably also in the y velocity direction, and it's just not gonna have been a perfect angle, and also there's other external factors like drag that wasn't accounted for, or also maybe there was like a little wind or air conditioner in the room that could have impacted how the ball flew. So for the conclusion, the what does it mean and what if. So what does it mean that the initial y velocity is 0, even though there was a movement in the y, so that might be one of the confusion. And that just means, as previously discussed, that the projectile of the motion was only initially projected in the x direction, which is horizontally, and initially there was no force that moved the ball towards the y direction, but however, because there was a net force of y, because mass times gravity, this did make the ball travel at the end downwards, and which made there to be a y direction travel. And what if the ball was thrown at an increased tide and without external force, would it have landed in the same distance? And the answer is that it would not have landed in the same distance, because even if only the y direction changed, it would have taken longer time for the ball to drop to the ground, which would have meant that continuously the ball would have traveled in the x direction because of the position update formula, and which would have made the ball travel distance increase. Thank you.